Today we're going to go over a few practice problems that involve differentiating a function. We're going to start off with practice problem 1. It's asking us to differentiate 2 times e to the power of 2 minus x times x squared plus 9. So we are aware that the derivative of e to the x, or e to any term, is equal to that term prime times e to the x. And so we can follow this formula. We already have e to the x. All we really need to find is e prime, x prime, which in this case will just be the derivative of 2 minus x times x squared plus 9. And for this, we can use the chain rule, I believe. No, sorry, product rule. So 1d2, 2 minus x, times the derivative of the second term, which is 2x, plus 2d1. So we are just going to write the second term plus the derivative of the first one, which is just going to be -1. So this is the derivative of the term that x is raised to the power of. And so we can just throw this in front of x. We have to remember to multiply this by 2. And so this over here is equal to 4x, 2 minus x, minus 2, x squared plus 9, times e to the power of 2 minus x, x squared plus 9. This is practice problem 2. It's quite simple. It's asking us to find the derivative of cosine x over x cubed when x is equal to pi. So first, let's begin by revisiting the quotient rule, which states that if you have a function, let's say f of x over g of x, you're going to want to write out, sorry, this should not be prime. You're going to write out the lower term, or the denominator, which in this case is g of x, times f of x prime, or the numerator, minus the g prime of x, which is just the derivative of the denominator, times times f of x, all over the denominator squared, which in this case would just be g of x. So you can memorize this by trying to put this phrase into memory: low d high minus high d low over low squared. That's essentially it. We already have the formula here. So let's try to find the derivative of this. We already have g of x. We already have f of x. What we need to find is g prime of x and f prime of x. So what is the derivative of the numerator? Well, the derivative of cosine of x is going to be negative sine of x. And the derivative of the denominator, which is x cubed, is going to be 3x squared. We might as well find what g of x squared is. And it's simply just x to the power of 6. So now we can plug these in. We can say this is equal to g of x, which is the denominator, times f prime of x. So that's going to be negative x cubed sine of x, minus g prime of x, which is 3x squared, times f of x, which is cosine x. And of course, that's going to be over, that entire statement is going to be over g squared x, which in this case is x to the power of 6, We can simplify this further by equating this to the negative sine of x, negative x sine of x minus 3 cosine x over x to the power 4. And you could draw out the negatives. It's not really necessary. But this is essentially the derivative of cosine x over x cubed. Oh, I forgot we should probably find it when x is equal to pi. So over here, this first term, negative x sine of x, when you plug in pi, you end up with 0, of course, because sine of pi is 0. So we can say that this over here is equal to 0 minus 3, and that's because cosine x is equal to cosine of pi is equal to 1 over pi to the power 4, and that's equal to negative 3 over pi to the power 4, and that is the derivative of cosine x over x cubed at x equals pi. All right, this is practice problem 3. It's asking us to find the derivative of arctan x times tan of x. Now we can solve this using the product rule. The derivative, you're going to want to write out the first term times the derivative of the second plus the second term times the derivative of the first, also known as 1d2 plus 2d1. So all we really need to find is the derivative of the first term and the derivative of the second, and then we can just plug everything else in. So what is the derivative of arctan of x? Well, it is equal to, I believe, 1 over 1 plus x squared. And the derivative of tan of x is secant squared x. Okay, so like I said earlier, 1d2, so we're going to write out arctan of x. 1d2, so the derivative of the second term, which is secant x squared, plus 2d1, so the derivative of the second term. Sorry. We're going to write out the second term, which is tan of x, times the derivative of the first term, which is 1 over 1 plus x squared. And this is the derivative, this is the derivative of arctan x times sine of x, times tan of x. All right, this is our final practice problem. We're trying to find the derivative of 3 to the power of sine x squared. Now, when differentiating exponentials, which is just a constant raised to the power of x per se, and we're going to call this function a to the power of x, a being an exponential. Like I said, when differentiating exponentials, you're going to end up with a to the power of x times x prime, so the derivative of x, times natural log a. So keep that in mind. This is the formula we're going to use trying to solve this. And as you can see, we already have a to the power of x. It's simply this entire function. Now we need to find natural log a, or natural log 3. So we have that crossed out as well. All we really need to find is x squared, which is just the derivative of this top function. So the derivative of sine of x squared, is pretty simple. We can just use the chain rule. So this is essentially equal to 2x cosine x squared. And that's really all the work we had to do for this function. Now we can just say that this is equal to natural log 3 times 3 to the power of sine x squared times 2x cosine x squared. And that is it for this problem and this video.